Hello and welcome to Maths with Jacob. This lesson will focus on perpendicular and parallel lines. When two lines cut each other or cross each other at some point, they are called intersecting lines. So here we have two lines, and this is where they meet or cross each other, right there where that arrow is pointing. So that is the intersection. That's the point of intersection. So that's why those lines intersect, because they cross each other or they cut across each other. When two lines intersect each other at 90 degrees, they are perpendicular to each other. So these two lines here, see there, they cross each other, but that is a right angle or 90 degrees. Okay, so because that is 90 degrees, I'll just try and do that as neatly as I can. Okay, there's 90 degrees there. So when that's the case, we use the word perpendicular. Now let's look at two simple examples here. If angle A is 42 degrees in that triangle, there it is there, find angle B. So we have to find this angle here. Okay, so that here is 90 degrees. We saw that before. And if the three angles of a triangle add up to 180, we already have 90 here. That means that those two there must add up to 90 degrees. Okay, so that angle plus that angle must add up to 90 degrees because we already have 90 here. So in order for those two angles there to add up to 90 degrees, this angle here must be 48 degrees. Okay, because 48 plus 42 gives you 90. Example 2, find angle ACD, which is this angle here, that one there. Well, we've got 70 degrees here, as you can see. That's a right angle, so that right angle also extends there. So basically that's 90 there and that's 90. So from the previous example, if that's 70, that means this one here must be 20, because 70 plus 20 is 90, 90 plus 90 is 180. The three angles of a triangle add up to 180 degrees. Now if that's 20, and this symbol here tells us that this angle is 90 degrees, that means angle ACD must be 70 degrees. Okay, because 70 plus 20 gives you 90, because there's the 90 symbol, see? So that whole angle must be 90, and 70 plus 20 is 90. Parallel lines exist side by side like railway tracks. They never meet or intersect. And these are the symbols here. Okay? They are the symbols there which tell you that those two lines are parallel. And here we have another diagram, but this time we've got this line cutting across. See that line there? It cuts across there like that. And we've named 8 different angles. 1, 2, 3, 4, 5, 6, 7, 8. So let's have a look over here. In the second diagram we have two parallel lines with a third line cutting across them. That's the third line here, that one. The third line is called a transversal. So that's the name of it, transversal. We can see that 8 separate angles are formed in this diagram, and they're numbered from 1 to 8. As students move on in their mathematics journey, they will learn that these 8 angles have a very special relationship. Some teachers might like to introduce this relationship now, if their students are ready, but they'll definitely meet this relationship in the near future. So this video has introduced the idea of perpendicular and parallel lines, and we've also seen the transversal, which cuts across two parallel lines, and we did two simple exercises involving triangles.